So the next topic is the section 2 of module 1, that is amplifiers. Okay, so under amplifier you are going to study about the type of amplifiers, gain, input and output resistance, frequency response, bandwidth, phase shift, then negative feedback and multi-stage amplifiers. Okay, so before going on to the topic, we have to know what is meant by an amplifier. Okay, so what is meant by an amplifier? Amplifier can be defined as an electronic device which strengthens the input signal. Okay, so suppose that the input signal is V in, which is a small signal, then the output will be a larger signal. V naught will be a larger signal. Okay, so amplifier is a device, electronic device, that strengthens the input signal to a higher value. Okay, so what it strengthens? It strengthens the voltage, current and power. Okay, so this is called as an amplifier. Imagine that if a person want to convey the message in a classroom, his or her sound is okay. But if the person has to convey the message in an auditorium, then the sound of the person has to be strengthened, right? Or it has to be amplified. That is called as an amplification, strengthening of the input signal. So the first topic under the amplifiers is the type of the amplifier, types of amplifiers. So if we take the types of amplifiers, okay. So what are the different types of amplifiers? So the amplifiers can be classified based on the size of the signal. One is size of the signal. Second one is by means of physical configuration. Okay. And third one is the way in which it processes the inputs, processing of the input. So these are some factors by which the amplifiers are classified. So based on these properties, the amplifiers can be classified into, we are studying 8 different types. Okay, so the first type is called as AC coupled amplifiers. What is meant by AC coupled amplifiers? Okay, the amplifiers which amplifies only the AC signal is called as AC coupled amplifiers. Imagine that you have an amplifier. Okay, so if this is your amplifier, the signal will contain both AC and DC components, right? If you use a capacitor in the input side, what is the property of a capacitor? It allows AC and blocks DC. Okay, so towards the input of the amplifier, it will pass only your AC signals. So the amplifier will amplify only your AC signal by using a capacitor which blocks the DC component. Such amplifiers are called as AC coupled amplifiers. Okay. The second type is called as your DC coupled amplifiers. So the second type is called as amplifiers. Okay. So what is meant by DC coupled amplifiers? Here you are not going to use the capacitor. You are eliminating the capacitor. You are going to pass both your AC and the DC components. The amplifiers which amplifies both the AC and the DC components are called as DC coupled amplifiers. Okay. Now the third type is called as large signal amplifier. So the name itself signifies the meaning, right? Large signal amplifiers. So what are called as large signal amplifiers? Those amplifiers which amplifies the large signals, input signals. So the range is from 1 volt to 100 volt signal or more. Okay, so such amplifiers are called as large signal amplifiers. So this is your third type. Now what is your fourth type? Fourth type is called as small signal amplifiers. Small signal amplifiers. So here also the name signifies the meaning. So what is meant by small signal amplifiers? The amplifier which amplifies the low level signals. Okay, that is, it may be in the range of microvolt. So which is less than 1 volt is called as small signal amplifiers. Okay. Now the next type is called as your, fifth type is called as your audio frequency amplifier. Audio frequency amplifier. So what is meant by an audio frequency amplifier means the amplifier which amplifies the audio frequency range, that is 20 Hz to 20 kHz signal, is called as audio frequency amplifier. The sixth type is going to be your wide band amplifier. Sixth is your wide band amplifier. Wide band amplifier. Okay, so what is meant by the wide band amplifier means the amplifier which amplifies towards a large range of frequency, that is from few hertz to megahertz range. Hertz to megahertz range signal is called as wide band amplifier. The seventh one is called as your RF amplifier. So what is RF amplifier? RF stands for radio frequency, right? Radio frequency amplifier. So radio frequency amplifier are those amplifier which amplifies the radio frequency range. So what is a radio frequency range? 20 kilohertz to 300 gigahertz. So approximately it the value is given as 100 kilohertz to 1 gigahertz. Such amplifiers comes into the category of the radio frequency amplifier. And the last type is called as your low noise amplifier. Low noise amplifier. So low noise amplifier is mainly used in your satellite communication, where it takes the weak signal and amplifies the signal. So you will be having negligible noise. So the weak signal will be amplified. That is called as low noise amplifier. These are the different types of the amplifiers. So what is your next topic? Next topic is your gain, right? So type of amplifiers is done. The next topic is called as your gain. So what is meant by the gain of an amplifier? What is meant by gain? So one of the important property of an amplifier is its gain. Okay. So what is meant by a gain is the gain can be defined as the amount of amplification by the amplifier. Okay, amplification. How much the output signal has increased in strength, that will be given by the gain value. Suppose let us take the amplifier, black box. Okay, amplifier. Consider this is your amplifier. So towards the input of your amplifier you will be having your V in, and towards your output you will be having your V out. The current towards your input will be I in, and the current in the output will be your I out. Okay. So this amplifier will be having a gain. Let me take it as, so this will be your input and this will be your output. Now, if I give 1 volt as the input signal, if the amplifier gain is equal to 50, your output will be equal to 1 into 50, which is equal to 50 volt. So here input is equal to, V in is equal to 1 volt and V out is equal to 50 volt. Okay. So what is meant by gain? The amount of amplification factor, or the amount of amplification by the amplifier will be is called as your gain. Now what is a gain? In this case the gain is given by 50. It is increased to output is increased to the value of 50. Okay. So mainly the gain can be classified into 3 types. So you are going to increase the strength of either voltage, current or power, right? So based on this the gain can be classified into 3 types. The first one is called as your voltage gain. So what is meant by voltage gain? Now what will be your gain? Gain in general can be defined as the ratio of output to input, right? Input. So what will be your voltage gain? The ratio of the output voltage to the input voltage. Ratio of the output voltage to the input voltage. So if I take output voltage as V out and input voltage as V in, then voltage gain will be equal to V out divided by V in. Similarly, current gain. Current gain is the ratio of output current to input current. Okay. So it will be given as I out divided by I in. What will be your power gain? This is second one, and the third one is going to be your power gain. Power gain will be equal to the ratio of the output power to input power. Output power to input power. So which is equal to P out divided by P in. Okay. So the output power voltage gain is normally given as AV, current gain as AI, and power gain as AP. Okay. Now this power, you know that power is equal to voltage into current, right? So I can write that your power gain is equal to voltage gain into current gain. This is another formula to find out AP. Okay. So your second topic is done. Now the third topic is called as your input and output resistance of an amplifier. So what is meant by input and output resistance of an amplifier? For example, if we take a amplifier, black box, this is your amplifier. So this will be your Ri, and here you will be getting R out along with a source. So looking, what is meant by input resistance means looking towards your input of the amplifier will give you the input resistance Ri. I can take it as Ri. Similarly, what is meant by R out is looking towards your output of the amplifier. As seen from the output towards your amplifier, it is called as output resistance. Okay, the output resistance will be the internal resistance. So what will be your formula? So input resistance can be given by the formula. Input resistance is equal to, you know that resistance is equal to voltage divided by current, right? So I can write that the input resistance is equal to input voltage divided by your input current. Now what will be your output resistance? Output resistance is again, resistance is equal to again the voltage divided by your current. So I can write that the open circuit output voltage to the short circuit input current, right? So in both the cases it is nothing but equal to voltage and current. So these two conditions apply if the amplifier is pure resistive. Okay. Now in case of practically you will be having inductors, capacitors, okay, connected together. So when the capacitors are connected together, the input impedance will be called as input resistance will be called as impedance, whereas output resistance will be called as output impedance. Okay, is referred if it is not purely resistive. So in conditions where it is not purely resistive, we call those as input impedance and output impedance. So these are the two properties of your input resistance and the output resistance property. So next topic, you have the frequency response of the amplifier. So what is meant by frequency response of the amplifier? Okay. So the frequency response of an amplifier is given by, okay, the diagram. It's a graph plotted between gain in dB and frequency in hertz. Okay. So what is frequency response? It can be defined as the response of the system at different frequencies. So it is plotted in semi-log graph, okay, because your gain is taken as decibels. Okay. Now if this is 0 hertz, how will you mark your frequency? 10 hertz. So here it is in hertz, okay? 10 hertz, 100 hertz, 1k, 10k, 100k, 1 mega, 10 mega, okay, 100 mega, 1 giga, it goes on. So this will be your gain in dB, okay? So frequency response is the response of the system. Which system? Is the response of the amplifier at different frequency. So the amplifier will not behave equal in all the frequencies. In low frequency and high frequency, the gain decreases. So this will be your response curve, okay? So this is your low frequency range, right? Here it is low frequency range, here it is high frequency range. You can see that the low frequency range and in the high frequency range the gain is decreasing, and in the mid frequency this is called as your mid band. So in the mid band you will be having a flat response, that is you will be getting the maximum gain, okay? So maximum gain means you will not have any attenuation. So this is going to be your maximum value. So gain, it can be either voltage gain or current gain or power gain, okay? So now this was your frequency response, okay? Now next is your bandwidth. So bandwidth expressed in terms of power or voltage, okay? Now so your gain is expressed in decibels, okay? Now here you will be getting the maximum gain. So let me redraw the diagram once again for power gain. So if this is power gain and here it is frequency in dB, okay? Now this will be your maximum power gain. Let me give it as P max. Now there is a point where your power becomes 50%, okay? The power has dropped to 50% of your maximum power. So let me take this as the 50% drop. So what will be the value here? It will be half of P max. It has dropped 50%. This is called as your minus 3 dB point, okay? So this point where this line cuts your response curve at 2 points. So at low frequency it is called as FL, and in high frequency it is called as FH. So FL is called as the lower cutoff frequency, and your FH is called as your upper cutoff frequency, okay? So lower cutoff frequency, upper cutoff frequency. Beyond this lower and upper cutoff frequency, there will be no amplification. The amplification will be done in the mid band where you have a flat response. This is how you know that what is the range of the amplification. For example, for audio signal, you know that the amplification will be done from 20 hertz to 20k. So here you will be getting in the mid band. So here the gain will be equal to 1. Similarly, if I draw the frequency response of voltage gain. So if I take this as voltage gain, then this is your curve, this is your frequency. Now this will be a maximum voltage gain, okay? So let me take it as AV max. This will be a mid band. So there is a point where your voltage gain drops to 70.7% of your mid-band value. So that is called as your minus 3 dB point. So what is the value here? 0.707 AV max. Okay. So I can tell that, okay, for power gain, the output power drops to 50% at minus 3 dB point, and your output voltage drops to 70% of the maximum gain, that is a maximum value, that is which is equal to minus 3 dB. The reason is that voltage gain in dB is equal to 20 log V0 divided by Vin, which is nothing but 20 log your voltage gain AV. Okay. Now power gain is equal to, in dB is equal to 10 log AP. Okay. Now I can tell that this minus 3 dB point is also called as half power point. Half power point. What is the reason? Because the power will be half of its maximum value. Okay. So these points, these 2 points, this minus 3 dB point is called as your half power point, in which you will be getting your lower cutoff frequency and upper cutoff frequency, right? Now your bandwidth will be given as the range of those frequencies, the range of the frequency where your amplification will be done. Okay, so it is given as FH minus FL, the difference between your upper cutoff frequency and the lower cutoff frequency will be giving your bandwidth. Okay, now what is your next topic? Bandwidth is done. So the next topic is your phase shift of an amplifier. So what is meant by phase shift? Phase shift means the angle, right? The phase angle. It can be defined as the phase angle between the input and the output. Okay, input and output. So angle means what will be the unit? Unit will be degree. It is measured in degrees. Okay. Now for example, if I take a CE amplifier, your input will be a sinusoidal signal, okay, V in. Now your output will be 180 degree phase shift. Means what? Whenever the input is positive, your output will be negative, and whenever the input half cycle is negative, your output will be positive. So you have normally 180 degree phase shift between the input and the output waves. Okay, that is called as your phase shift, the change in the phase or the angle by which the input and the output changes.